Hello everyone, welcome back to my YouTube channel Exploration with Sejal. So today we are going to see the fundamental theorems of calculus. So under this topic we have three kinds, that is fundamental theorem for gradient, then fundamental theorem for divergence and the fundamental theorem for curls. Let's see each one in detail. So suppose if I have a function f of x which is a function of one variable, then the fundamental theorem of calculus says that integral from a to b f of x dx into dx is equal to fb minus f of a. So similarly we can write dt, that is this is the total derivative, is equal to grad t dot dl. So if we substitute this total derivative here, so integral from a to b grad t dot dl is equal to tb minus ta. So this is the fundamental theorem for gradients. So note that this is a very important theorem which is used mostly in electrostatics. Now let's see the geometrical interpretation. So if I have a function f and if the function has two different values at two different points, let's say it has a value at this point, f of a value at a point and f of b value at b point. So we can calculate the difference between them like in two ways, either climb up the stairs to reach using a ruler to measure the rise at each step, or we can do fb minus f of a. So both methods will give us the same answer. So similarly this is what gradients do. So gradients have a special property, that is their line integral is path independent. That is because we know from vector calculus the vector identities that curl of a grad phi is equal to 0. So we know that grad phi, if the curl of a function is 0, that means there is a grad phi associated with it. And also the line integral of grad phi dot dl is equal to 0. So we have a corollary which is associated with this rule, that is integral from a to b grad t dot dl is independent of the path taken from a to b. And the second corollary that is associated with it is closed integral, that is closed line integral of grad t dot dl is equal to 0, since the beginning and the end points are the identical. So it's like tb minus ta, where a is equal to b, hence this tb minus ta becomes equal to 0. Now let's see the fundamental theorem for divergence and the fundamental theorem for curl. So according to the fundamental theorem of divergence, we have this integral, integral over d tau, divergence of v d tau is equal to closed surface integral of v dot dA. So this rule is very important in electrostatics, especially in Gauss theorem. So in Gauss theorem we have this divergence of electric field is equal to rho by epsilon naught, and we get this divergence of electric field as rho by epsilon naught from this kind of integral. So let's see the geometrical interpretation of this. So if V represents the flow of an incompressible fluid, then V dot dA is the flux that we saw in the previous video. Then the divergence is the spread out of the vector from a particular point. Then this is like a theorem which connects the volume integral and the surface integral. It says that the facets within the volume is equal to the flow out through the surface. So it is like if a thing is diverges from a particular point, that is equal to the flow through the surface, all 6 surfaces. Now let's see the fundamental theorem for curls, which is also known as the Stokes theorem. So according to the Stokes theorem, we know that closed surface integral of v dot curl of v dot dA is equal to closed line integral of v dot dl. So the geometrical interpretation of this is like this. So I have curl at each particular point. This is like curl of v dot dA, and I am doing over a surface that is equal to the line integral over a particular orientation. So this v dot dl is the circulation of v.